So here is another question on graphical analysis of one-dimensional motion. So it is given that the figure below, this one, it shows the speed time graph of a car. Okay, here speed is on the y-axis in kilometers per hour and time is on the x-axis in terms of hours. We have been asked to find the acceleration of the car in the first 2 hours, the next 2 hours, that is from 1 to 2 and then from 2 to 4, and in the last 2 hours, that is from 6 to 8. Then the total distance traveled by the car and the average speed of the car. Okay, so I have copied this figure here. So now we'll start. So this is the one-dimensional motion, so speed is same as velocity because direction is not changing. So if we say speed in one-dimensional motion in a straight line, it is the same as velocity if direction is not changing. Okay, if you see here, for the entire duration from 0 second to 4 second, 0 hours to 4 hours, this much here, it is a straight line with a certain slope, okay, with respect to the x-axis. So it is constant acceleration, uniform acceleration AB from 0 to 4 hours. Okay, so here if we see, if we want to determine the acceleration, which is the slope of this curve, acceleration in the AB portion, which is uniform, which is tan theta. Slope is same everywhere, tan theta, which is equal to final velocity or final speed, which is equal to 60 minus initial velocity, which is 0, by final time, which is 4, initial time, which is 0 hours. Okay, this is kilometer per hour, this is hour. So it is basically 60 by 4, which is equal to 15 kilometers per hour square. So it is nothing, final velocity minus initial velocity, final time minus initial time. Okay, so in the entire AB region from 0 to 4 hours, it is constant uniform acceleration 15 kilometer per hour square. So in the first 2 hours, that is from 0 to 2 hours, and the next 2 hours, that is from 2 to 4 hours, it is the same 15 kilometer per hour. Then focus on the BC portion in the last 4 hours from 4 to 8 BC. It also has a slope, but it is a negative slope. Let this be theta 1, this be theta 2. This is theta 1, okay, this is theta 2. So this will be BD by CD. Here it is similarly BD by AD. Okay, it is the same as BD by AD. Here also tan theta 2, which is BD by CD, which is, if we express it in final and initial velocities and time, final velocity is 0 kilometer per hour, initial, which is 60 here at the start, by here it is final time 8, initial time 4. It is minus 60 by 4, which is equal to minus 15 kilometer per hour square. So if you see, both the acceleration and deceleration curves, they have the same slope. Okay, acceleration and deceleration magnitudes are equal, 15 km per hour square, but just the sign is different. So we have determined the acceleration in the first 2 hours, the next 2 hours, and the last 2 hours. So this is for 4 to 8 hours, this whole duration. So 6 to 8, the last 2 hours is included in it, minus 15 kilometer per hour square. Then we have to determine the total distance traveled by the car. So the total distance traveled by the car is the area under this rectangle ABC. Okay, the total distance traveled by the car is the area of rectangle ABC, which is equal to 1/2 into AC into, which is the base and height, BD. AC into BD, which is equal to 1/2 AC, which is 8 hours, BD, which is equal to 60 kilometer per hour. So that is equal to 240 kilometers. The total distance is 240 kilometers. Okay, this. Then we have to determine the average speed. Now we know that average speed or velocity in one-dimensional motion, that is equal to total distance by total time. Total time, which is equal to how much? 8 hours. 8 hours. 240 by 8, which is equal to 30 kilometer per hour. That is the average speed. 30 kilometer per hour. So a very basic and simple question, okay, but still it's a good one to analyze, the one-dimensional motion of an object in a graphical way. Okay. So here is another question on graphical analysis of one-dimensional motion. So it is given that a driver of a car, it is traveling at 52 kilometers per hour, applies the brakes and decelerates uniformly, and the car stops in 5 seconds. Another driver of another car, it is going at 34 kilometers per hour, applies his brakes slower, late, and it decelerates uniformly too and stops after 10 seconds. We have to plot the speed time graph of the two cars, and then we have to find out which of the two cars it has traveled more distance after the brakes were applied, in a graphical way. Okay, so first we will plot the speed time or velocity time graphs. So let us draw. First we have is this, the speed axis, and then the time axis. Okay, let us bring it a bit downwards. Okay, extend it a bit upwards. Okay, this is the speed. We'll convert it into meter per second, because the time is in seconds, MKS unit. It will be suitable. So first, 52 kilometers per hour that is equal to 52 into 1000 meter by 3600 seconds. That is equal to, it is coming around, if we calculate, it is coming around 14.44 meters per second. And 34 kilometer per hour in the same way 34 into 1000 by 3600 meters, yes, seconds. It is coming around 34 into 1600. It is coming around 9.44 meters per second. Okay, so we will mark the points respectively like that. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we'll mark 2, 4, 6 duration. 2, 4, 6, 8, 10, 12, 14, 16, 18. Up to this it will be sufficient. And then similarly we'll mark 2, 4, 6, 8, 10, 12, 14, 16. Okay, that will be sufficient. 2, 4, 6, 8, 10, 12, 14, 16, and likewise 18 then. So here we have to plot the speed time graph. So it is said that one of the cars, it is traveling at 52 kilometers per hour, that is 14.44 meter per second, decelerates uniformly after the application of brakes, and the car stops in 5 seconds. Stops in 5 seconds means the velocity is 0. So 14.44, so it will be somewhere here. Let's use a different ink. 14.44, somewhere around here. 14.44, and it stops in how much? 5 seconds. So here, somewhere here, in between 4 and 6, 5 seconds. So let's draw a line joining these two. Okay, this is the speed time curve of car 1. Okay, this is the speed time curve of car 1. Okay, let's name it. This is O, this is, let's say, A, this is B. Then we have car, the second car, which is going at 34 kilometer per hour, which is 9.44 meter per second, that is somewhere around, let's say, here. Okay, here 9.44. that stops in how much? 10 seconds. It also, after the application of brakes, it decelerates uniformly. This is very important, uniform deceleration. That's why this, straight line with no curve, nothing, after 10 seconds. So here and here. So we'll draw a line, 9.4 and 10. Okay, this. So this is for car 2. This is for car 2. So let's name it OAB. This is OCD. Okay, OAB. This is for OAB for car 1, OCD for car 2. Now, if you want to determine the distance covered by these two cars after the brakes were applied, we have to, for car 1, we have to determine, for car 1, the distance traveled by car 1 after brakes were applied. It is the area of triangle OAB, which is 1/2 into OB, which is the base, into height, which is OA, which is 1/2 into OB, which is equal to 5, OA, which is equal to 14.44 meter per second. That is coming around 36.1 meters. Similarly, the distance traveled by car 2 after the application of brakes, it is the area of triangle COD, okay, COD, which is 1/2 into base, which is OD, into OC, which is 1/2 OD, which is equal to 10 seconds, and OC, which is equal to 9.44. That is equal to, it is coming around 47.2 meters. Okay, 47.2 meters. So obviously car 2 has traveled more distance than car 1. 47.2 meters is greater than 36.1. So again, a very good question on the graphical analysis of one-dimensional motion in a straight line. Okay.